So we have another exciting talk now. It's by Dimitri and Richard from Sigma Prime. They're going to be talking about protecting contract upgradability through sound proxy pattern usage. So please give a warm welcome to Dimitri and Richard.
Okay. Hey guys, my name is Dimitri. I'm a blockchain security engineer at Sigma Prime. This is my colleague Richard. We work in the same area, basically looking at security issues in DeFi protocols, EVM compatible smart contracts, as well as non-EVM stuff like client implementations. So today we're going to talk about sound proxy usage. Yeah, basically we'll cover what is a proxy, transparent versus UUPS proxies, and some best practices when it comes to implementation.
Okay, thanks. So what is a proxy? Well, one of the key attributes of an Ethereum or Ethereum-style blockchain is that basically once you've deployed your code doesn't change. There is one specific exception, but for the most part, this holds true. Once you've deployed your contract, your code isn't going to be modified. It's not going to change. You can't change it even if you want to. And this has some upsides and some downsides. The main upside, of course, is that because your code isn't going to change, people can trust your code not to change, which is useful if they're going to put a lot of money or valuable tokens into your code. But it has the downside that if your code has a problem, maybe a bug, maybe a security issue is discovered, then you can't modify it, and you can't also upgrade to add new features. So proxying is a system which gets around this. It doesn't directly change your code. It works by sort of borrowing code from other contracts, which we will get into. So let's imagine we've got a proxy contract here. This is contract P, a proxy. And the proxy doesn't have much code of its own. It has a variable telling us where we're going, where the code we're interested in actually exists. And in my example here, that is inside contract A. Here is contract A, full of lovely code. So this is the code that you would write or the project developer would write. That's the code we're interested in. And proxy contract P is going to sort of borrow it. P does contain code as well, of course, but it's just the code to make a proxy work. So to have an example, we've just got a very simple set of code in A here. We've got a variable called number, and then we've got one function which gets it and returns it, and another function which changes it. And it works like this. Proxies work like this. You call the function you're interested in on the proxy, and then, like I say, it sort of borrows the code from the other contract, as in this example. So the function there only exists in contract A, and contract P sort of borrows the code from A, and then it runs it using contract P's own contract address, and it sets it in its own storage, right? If you note inside contract P there, we've got number equal 3. So we've set the variable inside P's own storage, even though the code was from A. And we can imagine, you can sort of duplicate this out. So imagine we had another proxy contract, just the same as P, but we've called it Q. It's also using the code at A. And you could then call the function on Q as well. And as you can see, because it's using its own storage, we've got a different value of number in the storage of Q. And the storage of A remains unchanged. We could, if we wanted, call it directly on A, like that. We're then modifying the storage of A. This is a different type of operation. It's the sort of more basic operation, right? And this is called a standard call. When we're talking about proxies, one of the key concepts to know about is that there are these two types of calls going on, a standard call and a delegate call. Now, a standard call, as the name implies, is the sort of call that you're used to, the calls that contracts generally make to each other if nothing else is going on, the calls that users make into contracts are standard calls, and they use everything of the contract. So there's called contracts code, the called contract storage, the called contracts address. The other type, though, that proxies use, and other code can use as well, is a delegate call. So this this is the sort of borrowing step that I'm talking about. This is using the code of the contract that you're calling, but your own storage, your own address, the caller's storage and the caller's own address. And so you get this sort of, what I'm describing as borrowing the code. And if we go back, this is just a diagram of everything that we've already seen. And I've just put the different call types onto the diagram. So contract A, the last thing we did is at the top there, that red arrow, that's just a standard call into contract A, modifying its own storage. Then at the bottom left, you've got the proxy flow going up that diagonal on P. And it starts with a standard call into P, and then sort of behind the scenes, if you will, contract P makes a delegate call into contract A to use its code and running with its own storage and address. So if we go back to where we were before, we've got rid of Q, let's move A over. And now let's say that we want to upgrade, right? So if we want to upgrade, what we do is we create a new contract, but note down in contract P, note where that red ring is, we've changed our variable. We're no longer using the code at A, we're using the code at B. And if we look at the code of B, B is just the same as A, but we've added this very simple function, which is just returning double of that stored variable. Just getting rid of A there, just to tidy up. And then if we call that function, our new function, on P, again, it goes over, it borrows the code from B, just as it did before. It's borrowing the new code that we've added. Note that it's running, though, again with P storage, so it's setting that using the value of number that we set previously, actually using the code of a completely different contract, right? It was contract A's code that set that variable in P storage, and now we're doing operations on it using the code of B. And that's the basic idea of upgrading.
Cool. Yeah, so Rich has basically talked you through how the logic of most proxy contracts work. I'll just quickly discuss two very common implementations. So we have transparent and universal upgradable proxy standard, just abbreviated to UUPS. And yeah, basically, we'll just do one like small, unofficial, like kind of bit of advice. We'd kind of prefer you to be a bit skeptical of other variants of these proxy contracts, just because they kind of add complexities. Only use them if you're absolutely certain you need to, like based on some specific use case. Transparent versus UUPS. So talking about what the similarities are first, essentially, they, like Richard said, they deal with storage in the proxy contract, they deal with delegate call-based logic, and they refer to a logic contract in order to actually update storage and actually process kind of function logic. In terms of the differences, well, it really is dependent on how the upgrade occurs. So in transparent proxies, the upgrade logic is handled within the proxy contract using a standard call. So just a regular function call, whereas on the UUPS side, contracts basically are forwarding all calls using delegate call, so it's the actual implementation contract that handles the upgrade process. So if we kind of zoom in a little bit more, so in transparent proxies, we need an admin user or a contract that's whitelisted. The admin user will call this particular fallback function, and in doing so, the transparent proxy knows that this should be something that is an upgrade process, because the admin would only ever call it during upgrade. On the UUPS side, it's forwarding all calls to the logic contract, so access control needs to be implemented within the actual implementation contract. Next slide. So basically, since the so on the transparent side, this is kind of a diagram kind of depicting this. Basically, we have the admin user calls the proxy contract. The proxy contract doesn't need to forward any calls to the logic contract. Instead, it just updates its internal storage slot for where the implementation contract is, and it will just change it from logic 1 to logic 2. Any subsequent user calls will be forwarded to the next logic contract. So that kind of basically solves your upgradability problems. So if you needed to change your logic 1 contract for something else, future calls will get forwarded to logic 2. So on the UUPS side, We have something similar, but because all calls get forwarded, the logic contract needs to decide if this is supposed to be a valid user calling the upgrade process. Then it will trigger a storage slot change in the proxy contract, and then the next logic 2 will be what other users are interacting with when all the calls that they are making get forwarded to the implementation side. So I was like initially kind of super confused about proxies when I first started. Understanding where the upgrade process actually really helps differentiate between the two. So it helps you kind of determine which proxy you should use. Now, it is worth mentioning that there is some gas overhead in the transparent side, and that's because they need to account for the logic changes or deciding whether the admin is a valid user or not to be calling the upgrade logic. So yeah, UUPS contracts are typically a little bit, have a little bit less gas overhead, and kind of zooming into that, for the transparent side, we can see this is actually the gas overhead that I'm talking about. So it's quite like a bit of a complex logic in terms of whether a user is able to upgrade or not. The key line really is just under the function call. Just checks if the message sender is the admin or not. And yeah, basically all other calls would just get forwarded to the fallback function. If the user isn't the admin. It's worth mentioning here that this call, this logic, this small gas overhead, is actually called on every single interaction with a proxy. So let's have a look at the UUPS side and see how that compares. So it's much leaner. This is only called when an upgrade is happening. So it minimizes the gas usage. Yep, and without any extra on UPS side of things, we will talk about some best practices with implementation. So when it comes to best practices, proxy contracts might not seem complicated, but it's because a lot of the logic has already been kind of abstracted away. And it's easy to like change a few things and kind of end up in a more complex situation again. So we kind of recommend you basically to basically don't use upgrade logic if you don't need it. Don't use complex unnecessary proxy patterns when they aren't required. And don't create your own version of a proxy when you can use EIPs that have already been built and tested. So often proxy patterns are kind of neglected, like a developer will build their suite of smart contracts, kind of implement proxy patterns without kind of maybe considering whether it's necessary or not, but just because it's on trend. And yeah, sometimes that can have some genuine security issues as a result.
Yeah, okay, so then we need to talk about constructors. So constructors kind of don't really work with proxies. And the reason for this is because of how constructors work. Constructors, although in a bit of Solidity code, they do look a lot like a function, they're not really a normal function at all. They just run when you deploy the contract, and then the code is basically just thrown away. So the constructor doesn't hang around as a callable function the way that all the other functions do, which means that you can't write a constructor in your logic contract and then call it with from the proxy contract. You also can't really do that sort of thing in the proxy very easily because, of course, all of the stuff that you use constructors for, which is sort of starting configuration, all that stuff tends to be kind of defined in the logic contract. All of your complicated variables and your mappings and structs and all this sort of stuff, it's all over there in the logic contract, and so not very accessible from the proxy. So the solution that we have is this thing called an initializer function. And an initializer is just a normal function that you write in the logic contract, and it's designed to be called by the proxy to do the job of a constructor. They're often called initialize or have names like that. They don't have to be called, that sort of thing. But that's how they work. They're called during the proxy's deployment usually to do that initial configuration using all the advantages of being able to code it within the logic contract. But they create dangers and complications of their own. One of the biggest issues with an initializer is that it's still sitting there on your logic contract. And it's possible for somebody to attack you by just initializing your logic contract directly, right? No proxy business, they just directly call the initializer and initialize it. And, you know, often they can't do that much harm this way, but you still don't want people poking around in your logic contract anyway. It's not a good situation generally. And there are some dangers, like catastrophically, they could potentially self-destruct your logic contract, which is obviously not good. So the main defense against this in Solidity, if you're using the Open Zeppelin proxy libraries, is this. You call this function here, this internal function, disable initializers. Disable initializers tells your logic contract that it's been maximally initialized. And you might be thinking, hold on, didn't you just say that we don't use constructors here and now here's a constructor? That's true. But the reason why we're using a constructor here is we're actually not dealing with proxies. This is protecting the logic contract from being directly called itself and interacted with as a contract normally, which is why this very limited constructor that just shuts down the initializer is useful.
So another thing worth mentioning is basically setting up and initializing in one transaction. So in proxy deployment, well, in proxy deployment and maintenance, usually we have one action, which is the actual deployment, where we release the proxy into the real world, and then the second action is initializing it, like Richard mentioned. So the thing is, if this is handled in two separate transactions, as some of you may be aware, transactions can get reorganized or malicious users can insert their own transaction in the middle. So this basically allows for someone to front-run initialization by initializing your contract for you. So not ideal. To avoid this, basically, we recommend you just do deployment and initialization in one transaction. Sometimes there's complexities around this where you may run out of gas doing both in one transaction. Then you need to think about how you're going to implement access control in order to split them across transactions to make sure a user can't just come in and front-run one of your initialization transactions. Kind of talking about the risk of not doing this, basically a malicious user could kind of take over your contract or potentially, mess around with the values that you would pass into the initialization.
Right, yeah, and we also have one little pitfall here, which is that it's possible to use both transparent and a UUPS pattern together, probably by accident. They're not actually mutually exclusive, and they are actually sort of technically compatible. They don't break each other. But it's probably not what was intended. Most likely it would happen because maybe you start with transparent and then without realizing sort of install a UUPS logic contract, or perhaps as misuse of a sort of automated installation tool. Somebody might accidentally set up both. And they will seem to work. Well, they will work. The danger really is just because it's probably not done intentionally, there's a much higher risk of human error here. Maybe the transparent proxies admin gets forgotten about, and maybe comes into the hands of somebody else in the future and does an unwanted upgrade, something like that.
Yeah, I'd like to just add a quick point on this without mentioning who it was. This was a quirky misconfiguration we found in the real world on one of our client engagements. So it's kind of easy to not consider what kind of framework you're using for proxy deployment and what the default values as to which proxy it's using. So it's worth checking that. Depends on what framework you use. So yeah, basically, another thing to mention is, as Richard kind of mentioned with delegate call logic, you're forwarding kind of control of a proxy contract to some other contract. So basically this sensitive opcode called delegate call is basically directly acting on the proxy contract, so it can take over certain storage slots, and it can even self-destruct the proxy contract. So it's really important to only pass in contract that has been vetted, so code that you actually trust. Yeah, and without further ado, I think that's it for best practices. Any questions?
Just about.
Actually, let me just get you the microphone. It's all recorded.
Yeah, so thanks so much for the talk. Just had one question on the transparent versus UUPS. So I remember seeing on like the Open Zeppelin library in the docs, and they had this like official recommendation to switch over to UUPS. So I'm kind of curious what might have prompted them to be like so opinionated. Is it just the gas overhead? Is it just one less contract to worry about, like because you don't need the proxy admin for UUPS, or if there's any other reason?
Yeah, those are good reasons. I mean, the fact that you've got a slight gas overhead on every single call is a perfectly good reason to prefer it. The other reason I've heard put as an advantage of UUPS is that you can shut down the upgradeability if you want to. If you ever want to, you can upgrade to a UUPS. Upgrade a UUPS contract to one that doesn't have upgradeability at all. But with a transparent proxy, because the upgradeability is baked into the proxy itself, you can never remove the code. You could try to make the admin unaccessible, but you can't remove that code entirely and sort of lock it in forever in a way that everybody can see as locked.
Okay, yeah, I think that makes sense. Thanks so much.
Okay.
All right, we have time for one other question. Right. Sorry, who was it?
I didn't quite catch the name of your company.
Oh, Sigma Prime.
Sigma Prime. Okay, thank you.
Okay, that was an easy one. Okay. Right, I think we got one.
Hey, thanks for the talk. What are your thoughts about the diamond proxy standard? I kind of see that a lot now. So depending on these two proxies, would you recommend going for that? I think there are advantages, but happy to hear your thoughts.
Yeah, it's a good question. Without kind of adding any negativity towards certain particular dev decisions, I do see that as an extremely complex pattern and not necessary if you don't need it. For the most part, it really solves being able to split contracts across different, like basically circumventing size limitations. And there's other ways we can do this. So yeah, I think unless absolutely necessary, probably you could just stick to UUPS or transparent.
Okay.
All right. Okay, one last question.
Thank you. What's the use case where one would use both transparent and UUPS at the same time?
That would be a mistake.
Okay.
An easy mistake to do, though.
Yeah, an easy mistake, to be fair, yeah.
Okay. Thank you very much.
Okay. Thanks very much.
Great. Let's thank the speakers, Dimitri and Richard.